we'll play through one more of these. Suppose we're given this set of parametric equations. X is equal to the negative sine of t plus t. Y is equal to cosine of t plus 2t. And this is on the entire real number line for the values of t. And we're asked to find the equation of the tangent line when t is equal to pi. So we're going to need y minus y value. Let's do it this way. We're going to need y minus the y value is equal to slope times x minus the x value. We need to find those values, and we need to find the slope. And we know that the slope is equal to dy dx evaluated at t is equal to, what's my number, pi. All right? So this should be pretty straightforward. We need to find the coordinates at time t equal pi, because that gives us the values for the constants. And then we need to be able to find the slope. So it doesn't really matter what order we do this in. So I'm going to say, let's see, we have when t equals 0, so x at t equals 0, or pi rather, is sine, let's make that, write it correctly, negative sine of pi plus pi. Y at t equal pi is given by cosine of pi plus 2 times pi. And what is that? That's 0 plus pi is equal to pi. And this is negative 1. Negative 1 plus 2 pi. This, I'll write this as 2 pi minus 1 quantity. All right? So that's the x coordinate. 2 pi minus 1 quantity. We'll take that into account when we distribute here pretty soon. And the x coordinate is just pi. So now what we need to do is find this value for m. And I'll go ahead and do this over here in the little corner. I think we have enough space for that. So we need dy dx is the derivative of y. Well, derivative of cosine is negative sine plus 2. Derivative of negative sine is negative cosine of t. In this case, now then plus 1. And then we want to evaluate that at t equals pi. So evaluate this at t equals pi. So that's negative sine of pi plus 2, negative cosine of pi plus 1. So what do we have there? That's 0 plus 2 is 2. And negative 1 is 1. Cosine of pi is negative 1. That's positive 1 plus 1 is 2. So our slope is equal to 1. So we have y. I'm going to distribute this negative sign. Minus 2 pi plus 1 is equal to 1 times x minus pi. Y minus 2 pi plus 1 is equal to x minus pi. And now move everything, get it in slope-intercept form. So move this across, add 2 pi, and subtract 1. So if we add 2 pi, we get pi plus 1. So that's the equation of the line. Y is equal to x plus pi plus 1. If you want, you can put this in parentheses and think of this as mx plus b. The y-intercept of that line would be pi plus 1. So it's straightforward. Find the derivative, evaluate it at the required quantity, and then find the individual points on the curve, evaluate the original functions at the given quantity for t, and plug the values into the point slope form, and you should be good to go. Remember that for any course I teach, when you're asked to find the equation of a line, it needs, with a few exceptions, it needs to be in slope-intercept form. So make sure you express your final result in slope-intercept form.